Hello, everyone. I hope everybody's listening and hearing and seeing me. I'm still trying to verify that. Geez, I always have problems lately with this. What's happening is that all these people are giving me two keys for, they're giving me one key for two videos. Oh, there I am. Okay, I think I'm online. Okay, give me a second here, get my bearings. Hello, Tesla. Thanks for letting me know that you that you see me. Okay, folks, let's get started here. We're going to be talking about uh, Jim Al-Khalili. This fellow is into, once a mathematical physicist finishes with physics, he's got nothing else to do because there's nothing new to invent in physics. There's nothing in quantum, there's nothing in relativity, and string theory is nonsense, and it's just math. They can't even figure out how they're ever going to be able to run an experiment, which they claim is part of the scientific method, to prove or in any way test the string theory, the existence of string, the vibrating strings, whatever they do over there, and so there's nothing more for all these people to do after they finish with quantum and relativity. And at that point, what do? Well, what they do, they start branching out. Some go into psychology, psychiatry, and consciousness, all that nonsense there. And others go into, like Al-Khalili, into biology. They want to especially introduce quantum into biology. They call it quantum biology. And that's what I'd like to talk to you about today. Okay, so what is Al-Khalili's argument in general terms? Okay, this is the bottom line with Al-Khalili and what he thinks, right? He says, heretofore incomprehensible biological processes today have explanations thanks to the fact that we, quantum mathematical physicists, stepped in to solve these long-standing mysteries for the biologists. That's essentially his argument. He's saying, look, you guys couldn't do your jobs. We mathematical physicists, they call themselves physicists, we had to step in to help you guys because you wouldn't be able to solve all this stuff because it all works at the quantum level. And so that's going to be his argument. And like I said last time, he starts out with a sales pitch in which he says that, quantum is proven, the theory of quantum is proven by technology. That's in the background, okay? Okay, let me put this here. And so he starts out with this bird known as the European robin, okay? It says it migrates constantly from merry old England all the way to Spain in the winter, I guess, and then comes back in the summer back to England. So it goes back and forth. And so he thinks this bird has something to do with entanglement. It's an entangled bird. And quantum entanglement, right? And why? Well, he says that it's going to use entanglement essentially to get its bearings. It's going to use the magnetic field of the Earth, which it can detect, okay? And so that's where he's going to go with this bird. He's going to show that this bird, part of biology, the study of biology, has lots to do with quantum mechanics, especially with all these new, or you could say new, I think in the last 50 years they came up with most of these irrational explanations for how the quantum universe works, okay? And so he starts out by saying the following. He says, for decades now, the robin navigates was one of how the robin navigates was one of the greatest mysteries in biology. And of course, that is until quantum came to the rescue, right? The most recent discovery has caused a sensation. It navigates using one of the strangest tricks in the whole of science. Guess what? It utilizes one of the quirks of quantum mechanics. Quirks, I would call it irrationality, right? I mean, let's use the right words. This is a world in which objects can spread out like waves. Quantum particles can be in many places at once and send each other mysterious communications. Now, how does that sound? Does that sound scientific to you? Just, first time you hear something like that? Okay. This is the only explanation that could bring all these results together. In other words, quantum, right? The robin has a biological compass somewhere in his brain. Apparently, according to Al-Khalili, says it has to do with it entering through his eyes, just like photons enter our eyes, right? It navigates using the Earth's magnetic field. Okay, so we got that rolling. Let me get this guy out of here. And so here's the entangled robin. Okay, according to Al-Khalili, says the puzzle depends on one of the truly mind-boggling ideas in physics, but don't worry if you find it hard to understand. He's already, warning you. You're not going to understand any of this. The way this happens defies all common sense. No kidding. So they're going to try to explain to you something that defies all common sense. That's a starting point. Now, go get your popcorn, your beer, because it's going to be lengthy. The idea is called quantum entanglement. It involves particles that seem to communicate faster than the speed of light. I thought Einstein proved, right, with special relativity, that nothing could travel faster than light. Here we are 100 years later, and these people still cannot accept that. On the one hand, they glorify Einstein, say, look, he proved, he demonstrated, he showed us that nothing can travel faster than light. And now the first thing they say, oh yeah, in quantum, that happens all the time. So which is true? I mean, does this debunk special relativity? How can they say this and at the same time glorify Einstein and say Einstein was right when here, they're saying the opposite? If Einstein was wrong, just say, hey, Einstein was wrong. Sorry. He was a dummy. He didn't know what he was talking about. No, they glorify Einstein on one hand for inventing the nonsense of relativity, and then they also want their cake and to eat it too. They also glorify quantum, saying, oh yeah, by the way, we do in quantum travel faster than light. Maybe gives hope to people who want to travel, to space, to the nearest stars, to colonize the galaxy. Maybe that's why they do it. I don't know. The idea is called quantum entanglement, okay? And extremely delicate experiments, very delicate, okay, have shown that subatomic particles really are entangled. In other words, they're connected, but we don't see the connections, okay? It means that they can subtly and instantaneously influence each other across space. In fact, we had Brian Greene saying that it doesn't matter if it's on the other side of the universe, that particle is entangled with the one here. Well, it sounds like they're connected somehow, right? Maybe we just don't see the connector. The same thing is going on inside the robin's eye. When a photon enters the robin's eye, obviously he's thinking a photon is a little particle, right? It creates what is called an entangled pair of electrons. So the photon enters and two electrons become entangled. Now, whether they were entangled before the photon came in, that's an interesting question we have to ask. But they always say that it's only when you look, when you try to measure that, you get these weird things, right? Like in quantum mechanics, the electrons are mysteriously linked. I guess he's describing the rope. Is he trying to steal my rope away from me? This is the ultimate secret of the quantum robin's compass. Okay, so what's the deal? They're inextricably linked. Okay, and a lot of this just sounds to me like spooky action at a distance, as Einstein mentioned or categorized it, as described it. Einstein didn't believe in quantum mechanics. To me, it sounds a lot like the Bible. It sounds like this, okay? You read these passages in the Bible, here you have entanglement, okay? Am I God at hand, said the Lord, and not a God afar off. For though I be absent in the flesh, in the body, yet am I with you in the spirit. So he's with us in the spirit. Okay, a particle is not in the flesh with the other particle; they're just in the spirit. Word spirit, brings me bad memories of dark ages. For with God nothing shall be impossible, and neither is it with quantum mechanics. Not only impossible, but there's no such thing as irrationality. Everything that they can think of is, even if they cannot imagine it, they say, yeah, it's okay. It passes the test. It passes quantum, and they just invent principles and laws to back what they're interpreting, the physical interpretation they give you. So since the physical interpretation makes no sense, it's idiocy, they have to create principles like complementarity and uncertainty and all these other nonsense they have, their entanglement and so on. Okay, here is entanglement, okay? Here's a simulation of what they're talking about. The guy sprays paint the statue, and the exact picture on the screen or on the wall there gets the same painting on the head. Action at a distance. Now, does that sound like science to you? Right off the bat. This is what these people are proposing. So is quantum a rational physical interpretation? Well, it doesn't seem like it, because here these people are telling you nonsense. They're saying there's this action at a distance without a mediator. It's instantaneous, and when you do something here to this particle, the other one immediately reacts to it. And if the other one over there reacts, that means the one on the other side of the universe reacts, and all particles in the universe react with respect to this one. It's not just one particle that reacts, because that's the one you measure. How about the others? The gazillions and gazillions and gazillions, or like Carl Sagan would say, billions and billions, right? What happens to all those particles? Are they also entangled to this one particle that you're touching? So you move all the entire universe with this particle? It does sound a lot like the rope, connected to everything. Then you can make sense of it. But without the connection, you're putting spirits. Then you're putting what God just said. He's with you spiritually, not in the flesh. Okay. Al-Khalili continues. He goes with the nose now. He says, why do you smell? What? I mean, why do you, smell with your nose? Not why do you smell, okay? For decades, biologists thought they knew how our noses sniffed different chemicals. But mathematical physicists believe there could be a new ingredient in the mix, and it smells like quantum mechanics. Ooh, I don't know. How does quantum mechanics smell? The standard explanation is that it has to do with the shape of the molecules, okay? The scent molecule has a particular shape that allows it to fit into the receptor molecules in our nose, okay? Triggering that unique smell sensation. In other words, what Al-Khalili says is that molecules from the outside, from the gas or whatever odors coming to your nose, lock in. It's like a lock and key mechanism where one molecule locks into your nose molecule, and if it fits, well, it gives you a certain trigger into the brain and says, oh, I see what I'm smelling. I'm smelling, perfume or whatever you're smelling. Okay? Garbage. The standard explanation is that it has to do with the shape of the molecules. Again, it's lock and key. Okay? The scent molecule has a particular shape that allows it to fit into the receptor molecules in our nose, triggering the unique smell sensation. So he asked now, so why would two molecules with different shapes smell the same? Okay, because there are odors out there that are the same as other odors, but they have different molecules. So he's trying to explain that. And he says, oh, we can do it with quantum. Okay, so how does he explain it with quantum? Well, he does a little dance here. He says, quantum biology has a head-splitting explanation. I'm sure it has. It's got to be head-splitting. It says our noses aren't smelling chemical molecules. They're listening to them. Yeah, you heard right. It's not just the shape of a scent molecule that matters. The quantum theory of smell is all about vibrating bonds. Bonds? Yeah, they're talking about, covalent bonds and chemical bonds, in general. It's like a particle of sound. Okay, they have the phonon, listening with our noses. That's what he says that smell is, according to quantum biology, quantum whatever. Okay, the new or the latest, I guess you could say, quantum explanations, decoherence, entanglement, superposition, tunneling, those kinds of things. He's referring to all this magical stuff they cannot explain, but they introduce as if they knew what they were talking about. Those are the physical interpretations. So you say in this case, it's a vibrating bond. Okay, what's happening? What he's going to lead you into is that the particle turns into a wave, and the wave can do anything it wants. It's all over the place. So whenever they need to cover the whole room, they use the wave. They can't use the particle because the particle is concentrated at a point. But, when they have to travel something, and say, well, this thing moves from here to there, that's when they bring the particle. Okay, even though there's a so-called physicist, mathematical physicist, who said it in reverse. He says, light travels as a wave and arrives and departs as a particle. These guys are saying more or less the opposite. He says, the particle comes from the sun or from wherever, and when it reaches the biological molecules that it's going to hit, it disperses into waves. It just turns into waves, and because it has to cover the whole cell, the whole molecule. It has to act simultaneously everywhere. And since they cannot explain it, they have to bring these notions from quantum mechanics. Okay, that's where they're headed with all this. Okay, so what does he say? This is what he's referring to. He's saying, look, these are the vibrating bonds. Okay, and the question is, what are those Bedsprings? I mean, I don't see them in the standard model. So what are they referring to when they say bonds? What are they talking about? And of course, they'll never answer that because they don't have a physical entity to put into that word bond. When they talk about bonds, they're talking about abstract descriptions, mathematical descriptions. They're talking about force. They're talking about energy. They're talking about charge. They're talking about a lot of nonsense, but they're not putting a physical object in there for you to see. And they put a bed spring, and you say, is that what the bond looks like, a bed spring? No, that's just a simulation. You're not supposed to take it literally. Then what is there? What's holding two atoms together to form a molecule? And that's when they run into trouble, because that's when they start talking about orbitals and whatever those orbitals are, because what is an orbital? It's just a region where you can find the electron bead. So it's like you never get a straight answer. You never get an object. You never are able to visualize a physical object in there, and they'll never put one in there because they don't deal with objects. They're all mathematicians. That's why you won't see it. Okay, so what is a phonon? Okay, here it says, okay, phonon. Phonon, collective excitation in a periodic elastic arrangement of atoms or molecules in condensed matter, specifically in solids and some liquids, okay? Often designated as a quasi-particle, it is an excited state. Whatever an excited state is, I don't know, New York, California, those are excited states. In the quantum mechanical quantization of the modes of vibrations for elastic structures of interacting particles. Phonons can be thought of as quantized sound waves. Now we have sound waves, and they're quantized. They're going to turn the wave into a particle, okay? Similar to photons as quantized light waves, okay? So now they take this longitudinal wave, they're going to turn it into a particle like I showed right there at the bottom, okay? Quasi-particles, emergent, what are they? Those are emergent phenomena that occur when a solid behaves as if it contained different weakly interacting particles. So what are quasi-particles? They're phenomena. What are phonons? They're excitations. All these are verbs. What have they done? They've turned them into particles. They've turned the vibration, the excitation, the waves, they turn them into particles. And yeah, when you can do that, then you end up with something like this. Here I've tried to illustrate that. Okay, you've got all these particles that are vibrations of longitudinal vibrations of sound, but they're like drops of sound or particles of sound that travel through the air. So it's not only vibrating locally, turning into a particle, which is what they're dealing with here, but these things are traveling. So it's the wave particle duality. Particle always, whenever they can't answer a question, they turn it into a wave. Whenever they can't answer the wave, they turn it into a particle. And you keep chasing your tail around trying to figure out what these people are talking about at any point in time. And yes, you will not be able to figure it out. Aside from the fact that there is no such thing as a wave. You have to identify what it is that is waving, and they never do that. They just say the particle turns into a wave. What does that mean? It turned into a concept, it turned into a verb. What is a wave? Wave is just a verb. It's what something does. The ocean waves, the water is the matter, is the thing, the object. What it does is wave. There is no physical object called wave, not in physics. In ordinary speech, yeah, but not in physics. And so this is the problem, that they're using words that they are treating as physical objects, and wave is one of them. Okay, he doesn't stop there. He continues, and now he's going to talk about another phenomena of quantum, which he wants to introduce into biology, and he uses the tadpole turning into a frog as an example. The transformation from a tadpole to a frog has never been fully explained, but the big mystery is how it happened so fast. Well, the queen there, the girl, she was able to kiss the frog and turn him into a prince instantaneously. So I guess they just need a quantum kiss or something. I don't know. What is this guy talking about? How something morphs from A to Z in a split second? Well, let's see what he has to say. A tadpole is held together by long ropes of proteins knotted together by chemical bonds. Again, chemical bonds. And it looks like he's talking about the ropes, right? Because he's always introducing an elongated object to do his explanation, but he never identifies that. He just talks about all these concepts such as bonds and waves. He never really comes in there and said, this is the physical object that's in that invisible world, which is what he should be doing. Okay? He doesn't do that. Enzymes are the little machines inside the cell that do the chemical transformations. Okay? The enzymes inside the tadpole snip the collagen into small pieces. That's their job. Okay? But how do the enzymes break down the molecules apart so incredibly fast? They're going to chop the bonds, whatever the bonds are. We still don't know what the bonds are, but they're going to chop the molecules into pieces, meaning they're going to break those bonds, right? To do this, enzymes have to move protons about. Okay, so we're going to be moving protons, not atoms. They're going to be moving protons. Okay, but this takes a lot of effort, meaning energy, right, and time. Too slow to justify the metamorphosis. Okay, so he's going to break the molecule apart. Let's see what he does with that. He goes in there and he says, look, this is a definition of a chemical bond, by the way. We had to look it up to find out if there's any, maybe there's something I don't understand, about what the word bond means. Chemical bond is a lasting attraction. Attraction is a verb. So if that's what a chemical bond is, all they're talking about is a verb. Between atoms, ions, or molecules that enables the formulation of chemical compounds. Again, attraction is a verb. So if a chemical bond is a verb, it's not a physical object. It cannot be used as a physical object, and you can't say you're going to break what is not a physical object. So I don't know what Al-Khalili is going to break. If he's going to break a verb, he's going to break a run or a fly or a swim. What's he going to break? A jump? The bond may result from the electrostatic force of attraction. So what is a bond? A force of attraction? We still don't understand. We have verbs. All we have is force, which is a verb, and attraction, which is a verb. Between oppositely charged ions, as in ionic bonds, or through the sharing of electrons, as in covalent bonds. Well, if you share something, you still haven't told me what the bond is. What do you mean share? What are you sharing? Are you sharing a rope? You know, I mean, if we're sharing a rope like this, then we can understand it, but he's got to identify that object. What is it that they're sharing? Are they sharing love, information? What are they sharing? So it's all concepts. At no point does he introduce an object in his entire dissertation. Okay? And yeah, he continues with concepts. He continues with it. He says, look, enter quantum tunneling. Obviously, he's got to introduce that. There's an energy barrier. The proton needs to get to the other side. In other words, to do its breaking up and so on, right? Rather than jump over the wall, the proton tunnels through as a phantom through a brick wall. Yeah, I mean, what are we talking about? Religion here? We're talking about phantoms, angels, spirits, or are we talking about a physical object? Are we talking physics or religion here? Without quantum ghosts, his words, not mine, ghosts, phantoms, spirits, angels. That's what he's talking about, okay? Without quantum ghosts, the metamorphosis of a tadpole into a frog would be impossible. Yeah. Sounds like he's talking religion. I thought he was going to talk about physics, something about physics, but it turns out he's bringing ghosts, phantoms, spirits into the dissertation. Okay, and so this is how he does it. He has this cannon, atomic cannon or whatever, the enzyme, and it's going to shoot the proton cannonball right through the wall without making a dent in the brick. That's what he's going to be doing. Okay, so he's not going to shoot over the wall. He's going to take the shortcut. Like the relativists take a shortcut to get to another star. They instead of going at the speed of light, they just take a wormhole and cut across all that distance by taking the shortcut. Right? These guys are doing the same thing. He said, "Don't jump over the wall. That takes too much time, too much energy. Just go through it." And I said, "Well, I can't go through it." "Oh, yes, you can." See, whoom. And they just do it. Magic. Take magic wand and say, "We did it." Now, does that sound like science to you? Or this sounds like religion to me. I don't know. Traditional religion. Okay. Okay. So here's a proton. This is what it looks like, more or less. You got the 3 quarks there. We don't know why they don't fly apart. We don't know what that big ball that's holding the 3 balls in there is. What is that ball? Can you make a ball, a sphere with 3 little balls? Here's your challenge. Bill Gaede's challenge to you. Take any 3 balls, tennis ball, golf balls, footballs, whatever balls you want, right? And see if you can make a ball with them. I was able to make a triangle more or less, but not a sphere. And these guys have this sphere there, which is supposed to be the proton. It's got to be spherical. And what's holding them together? Well, it's this gluon, this strong force. And as you can see, they don't put how it's held together, but we know how it's held together. We saw that in a couple videos ago where we have the Bedsprings, okay? So that's how they're held together. Okay, so that's the proton, okay? And now you're going to take this bowling ball compared to the electron, right? 1,800 times more massive, okay? He's going to take this proton, he's going to shoot it, okay? And they're going to shoot it along the accelerator, okay? Well, how do they know they're handling a proton? I mean, they've never seen an atom. Here they're saying they're stripping an electron from the atom, they're leaving a proton, and they're going to accelerate a proton. This is what they're saying that they're doing. This is their physical interpretation. Well, I can just as well say that what they're accelerating is actually, an angel maybe. Here's the angel. Maybe that's what they're accelerating. I mean, I don't know. You tell me. How do they know they have a proton in there? And here's one way that they would show us that they're actually accelerating a proton, and that's by starting to identify, the atom. If they can tell me what their atom looks like and how that electron bead remains faithful to the proton to begin with, before you do anything with the atom, right? Then we can conceptualize what they're talking about. Right now we have a problem with the atom, with the quantum atom, because we don't know what that golden or yellowish center is that is between the proton and the electron? We don't know what that is. Please identify what is that. Well, Rutherford says it's empty space. Al-Khalili said the other day that based on the people who educated him, educated, that stuff is made of particles. So we have electron is bound to the proton by particles. Okay, let's concede particles. How did they do it? How do all these gazillions of particles between the proton and electron, which they say is empty space, the empty space in it, how did they do it? Tell me the mechanism. Are we talking about sand? Are we talking about a gas? What are we talking about? What is that yellow stuff there, in between the red proton and the purple electron? We need to identify that stuff. Otherwise, we can't explain or justify why the electron remains faithful to the proton to begin with. And so, yeah, again, these people are saying they stripped the electron, they accelerated the proton. They could be just as well saying, hey, we accelerated an angel. No difference. Okay, he does another magic trick, his fourth one. He says, look, here we have life in the form of plants, and they receive all this photosynthesis. They manufacture, they have this process in which they manufacture all this biomass on Earth. Okay, he says at this very moment there is a bullet passing on the other side of Venus, coming towards the Earth, and has this tree's name on it. That bullet's going to hit the tree, right? That bullet is a photon, nearing the end of its long journey from the sun. Okay, you see the picture there? Okay, that's essentially what he's talking about. He's saying light consists of photons, and if we look at just any single photon, he's talking about a little particle, maybe a packet of a wave packet like we just saw with a phonon. Okay, so we have this packet of energy, this packet of waves or whatever it is, and it's going to come and hit the tree. Where does he get this? Well, he got it from his antecessors, people who told him that this is what they proven, and so he just believed it because he went to college and he says, oh, okay, that's what I memorized, and this is what I was taught to repeat by rote. Okay, so that's what he's doing. Okay, but let's concede. So we have this little particle. Okay, let's find out what he does with it. He's got this little, because he's going to explain something in biology with this nonsense. Okay, so let's find out what he does with it. He goes in there and let's see, I lost what I was going to put in there. Give me a second here. I think it's this one. Oh, yeah. Okay, so he's going to take this photon. He says it's going to do something. When the photon hits the cell, okay, a cell, biological cell, right? It knocks an electron out of the middle of the chlorophyll molecule. This creates a tiny packet of energy, whatever that is. Okay, Richard Feynman, Nobel Prize, he said, we don't know what energy is, but he's talking about a packet of what they don't know what it is, called energy. Okay, fine. Called an exciton, which he calls exciton. He calls it exciton, I think, so that people don't know where the word comes from. No, it comes from exciting, from excitement, from excite, the verb excite. And that's why it should be really pronounced exciton. I like that better. It also rhymes with phonon and photon, exciton, right? They're all, I think that's the way it should be pronounced. The exciton bounces its way through a forest of chlorophyll molecules, okay, until it reaches the reaction center. That's where its energy, whatever that is used to drive chemical processes that create the biomolecules of life. Great. We still don't understand anything because we don't know what physical objects we're dealing with here. We've got all these concepts, okay? The exciton wave, I thought it came in as a particle, the photon, and hit. All we had was particles. Suddenly that turns into, it talks about a packet of energy, okay? Packet, you would think it's, compressed, a little bundle, something, Now he says, now it's a wave. It's a spread out wave. He suddenly turned it, magically, without you noticing, turned it into a wave. He had that up his sleeve. the exciton wave is not going this way or that way. It is following all paths at the same time. See, you see why he had to convert it into a wave? Okay, because he needs for it to cover all the bases. Here you have one player, right? The guy hits, and he doesn't go to first base. He doesn't go to second base. He doesn't go to third base. He's at all three. He covered all the bases. Okay, so that's how it works in quantum. Man is at three bases at the same time. Same guy. Okay, same great player. I'd love to have him on my team. Okay, so what is an exciton? We have to look it up because all I've got so far is that some kind of energy thingy, okay? So you look it up and, well, I think I found it in a standard model. I think you'll find it in there somewhere, okay? An exciton is a bound state. Again, what is a state? Of an electron and an electron hole which are attracted to each other. Again, attraction, that's what it is. By the electrostatic Coulomb force. Force is a verb. So here they have this word force, which is a verb, okay? And they talk about attraction. Again, we have this verb of a verb, force of attraction. So far, all we have is verbs. We still don't have a noun. We don't know what physical objects is mediating this whole transaction. And in physics, we can't use verbs of ordinary speech or nouns of ordinary speech and introduce them as nouns in physics. No, in physics we have to be very discriminatory. We go in there and we analyze what the guy is introducing. So if you introduce the word orbital, that might be a noun in ordinary speech. For the purposes of physics, orbital is a verb. The word motion is a noun in ordinary speech. When you introduce it into physics, it becomes a verb. So all these are verbs. Force is a verb, and so this exciton, which is an attraction or a force of attraction, is all it is a verb. So far we got verbs. So we're moving verbs around. Okay, it is a quasi-particle. What was a quasi-particle? A maybe particle. One that is not quite a concept or an object. It's somewhere in between. It's in this limbo, in this no man's land. Okay. The quasi-particle that exists in insulators, semiconductors, and some liquids. The exciton can transport energy, verb, without transporting charge, more verbs. So far we have is, what is a charge? It's a charge is any of different quantities. In the case of what he's talking about, electrical charge, it's 1.6 times 10 to the minus 19 coulombs. So that's a verb, that's just a number. Number is the verb to count, that's all it is. That's the meaning of the word verb, the word number. Number is a verb for the purposes of physics, of science, right? And so he's moving 1.6 times 10 to the minus 19 coulombs, which is a relation. That's it. That's what he's moving. So far, we understood absolutely nothing about this excited exciton, okay? And here's the coherence. This is how they typically illustrate it. Okay, in quantum physics, an atom can be excited and not excited at the same time. So we have excited and not excited, and they can be at two locations or positions, as they call it, at two places at once. And they can be at many places at once. Okay, so if you're going to introduce magic, you can do anything you want. I mean, is this an explanation, a scientific explanation? Are we listening to a scientist or a preacher, a preacher of the Dark Ages, a monk? I mean, this guy is just introducing, for all his processes so far, he's just introduced magic. And it's irrationality because, I can do magic too. I can say, look, I created this rabbit from the hat. And someone asked me, what's a trick, Bill? How did you do that magic trick? No, it's no trick. I actually did create the rabbit from empty space. Length, width, and height, bloop, here you have the rabbit. That's what these people are doing. And they call that science. And they say it's been proven. No, they haven't even proven it. What they've done is they said, look, we saw something in the lab. This is what we saw. And when they bring it in, they interpret it according to the particle hypothesis. And of course, you cannot explain the subatomic world with particles. That's the problem. And so when you try to explain it with particles, you have to introduce magic. You have to do, spirit. You have to do excitons. You have to talk about positive and negative. You got to talk about a lot of energy, wave packets. You got to talk about a lot of nonsense because because you can't explain it with particles. That's the problem. And so the particle can be at a given point in time, a given location, but then for the effect that you observe, it's got to cover the whole room. And how do you do that? Well, you say, very easy. I turn the particle into a wave, a spherical wave of sorts. And so it covers the whole room instantaneously. Wave of what? And they say it's a probability wave. Wave of probability. That's it. You won't get any farther than that. And if you didn't understand it, they say, well, you got to take 10 years at the university like they did, and then you'll understand it. Well, if you understood it, how come you can't explain it? How come you can't explain it to a barmaid or what, a 10-year-old kid? Okay, so let's go with a summary. And here we have it. Give me a second here. Summary. Quantum entanglement is the mechanism whereby a particle here affects another one over there without any mediating agent. In other words, magic. Bond vibrations fail to identify the physical object that serves as mediator and does the bonding. Again, magic, because if you don't have an elongated mediator between two atoms to do your molecular stuff, your crystal lattices or whatever, then you're doing magic. You're saying this atom vibrates, the other one vibrates, they're all vibrating. Why are they vibrating? Well, because of the bond. What bond? What is this bond? James Bond? What is this bond? And they'll never identify the bond, especially like hydrogen bond, which is from a distance, like the covalent bond. They more or less, they try to get by saying, look, it's the orbitals that more or less merge, which is again what the rope model proposes with real objects. But they say it's the orbitals, they kind of overlap. Okay, how do you do hydrogen bonding, which is just a little line that connects to like the oxygen to the hydrogen, right? How do you do that? Well, then they have no no answer for that. They don't have they can't put what are they going to put, a line? They can't put anything for a bond, for the word bond, a physical object. They just talk about bond and energy and charge and field, but they will not put a physical object there. They'll do it, with a line, like in the stick and ball model. But when you ask them, well, is it a stick? Is it a little line? What is that line? That's where they fall back and say, oh, you got to go 10 years to the university to understand what that line is. That's the answer you're going to get. Okay, a phonon is an abstract concept that the mathematicians morphed into an object because they have no clue what invisible entity is doing what they are observing. See, they can't explain this with particles. That's the issue. A quasi-particle is a verb that the mathematicians converted into a noun. Okay, again, it's all these verbs, these concepts. A quasi-particle is a verb, right? Tunneling is a physical interpretation in which a quantum cannonball goes through the walls without causing a dent in the brick or mortar. So, yeah, I mean, if you can shoot a cannonball through the castle wall without even touching the wall, maybe it doesn't even kill the soldiers on the other side either, because what is this? Is this an abstraction that you're shooting? What are you shooting? Explain the process, the mechanism by which the proton avoids breaking the bricks of the castle. That's what you need to explain. If you can't explain that, you don't have a theory. All you did is magic. And then the quantum decoherence, which is the last part, means that a stone thrown in the lake morphs into the water waves that disperse from ground zero. So you threw a stone, you threw a nickel in there, right? Or it fell. And you see all these waves. And you say, oh, I'm going to look for my nickel. No, don't look for it. It went with the waves. The waves, the nickel turned into those waves that spread out. You lost it. You lost your nickel. Okay, so Al-Khalili explains all this, and so the question is, where does he get all this? And did he just memorize in school? That's it, to get his degree, to get a good job and a career, that's it? That's all he does? He never thought, he never used his brain for anything. He just memorized, studied for the test, and passed. That's it. That's how he got through mathematical physics. That's how he got his degree. And he will say that he stands on the shoulders of giants. Okay, that you had all these giants in the past, Einstein, Newton, maybe Rutherford. And so here we have Atom Man Al-Khalili. We saw him a couple of weeks ago. Yeah, and he's standing on the shoulders of two giants there. Niels Bohr and Feynman, both Nobel Prize winners. These people believed in quantum. They passed it on to him or to his teachers and then to him, whatever. So this is where he got it. He got these ideas from these two fellows, essentially, and others, right, like them. And the question is whether these guys are giants or he thinks they're giants in his little mind. He thinks they're giants. Maybe when we look deeper, these guys are just mental midgets. That's all they are. That's all they were. And maybe ants are bigger than them. That's my conclusion on good old Al-Khalili. Okay, so I don't think he's. What can you say about a guy like that? This guy who just memorized because he never even questioned whether what they were teaching him has any validity whatsoever. Maybe he said, "Well, that's so strange. That's so weird." Well, if it's weird, where's your skepticism? Where is your where are your rejoinders? Did you question your teachers and say, "Hey, this sounds irrational to me"? And they convinced him that it's okay to be irrational in quantum. Is that it? And they kept going. Is this how his teacher memorized? And is this how his teacher got memorized decades after decades? So all we're passing around is all this nonsense and nobody questions it, whether any of this has any validity. This has to make you stop and think. We're in a very strange world today. Okay. Let me get on with the fan mail. Had some fan mail today. Okay, let's see what we have here. We have start over here. One of these I think had something to say about whether I address comments. Well, yeah. What am I doing now? I'm not addressing comments, so I do address comments. Maybe you're not watching. I don't know. But yeah, I address comments now. Maybe I don't address all the comments. I may have missed one or two here, 3 or 4. It happens. I can't. Part of the time I can't even find all these comments. Or I've got comments from different directions. That's one issue. The other one is that even if I did find the comments, not all of them are pertinent or I'm interested in discussing it. And it's not because the guy insulted me or whatever. It doesn't matter to me. If the guy raises an issue I'm interested in, I'll bring his comment in, believe me. And so I don't know. I don't know what this guy's problem is. Yeah, I do address comments. I lately what I'm doing now is addressing comments at the end of the presentation. So maybe, I don't know, maybe he didn't stay that long to see the comment. I don't know. Let me get this thing out of here. Okay, next comment. Let's see what we got. It says, it is quite obvious why you can't touch the ropes. Okay, if that first atom on the left, and I put it on the bottom here, is one of your finger atoms, regardless of which element, then your attempt to touch the rope along the so-called x-axis would merely result in your atom sliding through it, not touching it, and lead to bumping onto the second atom on the right. Yeah, he said a couple more things. I'll just clarify the following. If you are staring at two atoms, right? Let's assume you had God's eyes, right? And you had the atoms, in front of you, side by side, like you see them there. Well, your eye, the atom in your eye is connected to each one of those atoms, but it's not connected to the rope. So you cannot see the rope because the rope is not connected to your eye. The rope in your eye, the atom in your eye has to be connected to another atom. So you can't see the rope. You can see another atom, but never the rope that is in between your atom in the atom in your eye and the atom that you're trying to, or the atom that's on the other side of the rope. So yeah, you can't see the rope. And yeah, Mother Nature, God, the devil, whoever it was, they were smart, and they made the ropes invisible and intangible. For otherwise, we would be in a tangled mess. If we could see the rope, that's all we would see practically all day long. Just like if she would have made air visible, that's all you would see every day. All you would see is air. You'd be blind essentially. Okay, blind men, they see air every second of the day. That's a good way of putting it. Okay, because you would be blind essentially. Okay, ether as a mediator for light is a network of forces. Well, then it's a concept, because if forces, there's no physical object called force. That's a concept. Maybe in ordinary speech, it's a noun. In science, it's a verb. So you can't say force. Okay. And particles, atoms are simply the foci of those forces at the intersection of those forces. Again, forces, forces, forces. We're not talking about horses, we're talking about forces. And forces is not a noun for the purposes of physics. Okay. And he continues with force and talking about forces being the mediator of the ether, or that the ether is made of forces. No such monster. So, in the Muslim world, in Islam, there's something called a fatwa. A fatwa is when one of these big guys, these theoreticians of the Quran, he issues a fatwa, which is a ruling that must be followed. Sometimes, like the Ayatollah Khomeini, he issued a fatwa to someone who offended the religion. That means that he's fair game for any Muslim. Someone can go out there and do some damage to that guy, right? So, fatwas can be interpreted in different ways, okay? Well, Bill Gaede also has a fatwa, and it comes to in the context of what this guy is saying. Here it is. Here's Bill Gaede's fatwa, okay? And that is, anyone who uses or introduces the following words as objects into physics shall be treated with the respect that he deserves. And the first 5 words there at the top, force, field, energy, mass, and time, they are forbidden in physics. I have issued my fatwa, my ruling, and you are fair game. Okay, so never use any of those words there. Okay, ether, plasma, electricity as physical objects. They're not physical objects. If you haven't learned that, you haven't graduated from kindergarten physics yet. Okay, so you're still in kindergarten. You're still playing with little blocks. You still can't even ask the questions because you don't understand the foundations of physics. You don't understand what science is yet. Okay. Here's another comment. Fellow says, Bill Gaede thinks science should explain nature and not do anything else. Uh-huh. Yeah, that's what it's supposed to do. It's science is about explaining, okay? And where do we get this? Well, we get this from the definition of science, okay? So here's the definition, okay? Science, rational explanation. Physics is the rational explanation of mechanisms. We're pretty much done. So as long as you follow the definition, you won't get hurt, okay? We will not bang you over the head with the dough roller. Now, you may not like that definition. Good. You have a single recourse, and that is to, give us your definition. Here we have definitions from the scientific, from the mathematical physics world, okay? And you can see that they don't know what science is. They have all these definitions, okay? And one guy says systematic study. Another one says it's organizes knowledge, testable explanations. Just now we had explanations which Khalili admits they don't understand. So what they're going to test, they're going to test the description, but not the explanation. First, you can't test an explanation, but right now they're admitting to you that they don't understand what the mechanism is. So they don't have an explanation other than magic. So if that's what science is, well, then that eliminates quantum mechanics completely. Okay, predictions, that's a description. A prediction is without an explanation is a description, and if it's an explanation, it's not a prediction because then you can only explain the past. Okay, like these guys predict, what happened at the Big Bang. That's the kind of predictions they do. They predict the past. Science consists of observing the world by watching. Now you can watch all day and not understand anything. So observing is worthless. You have to think in order to explain. You have to rationalize. Otherwise, you observe, you can gawk, you can drool. Does that mean you understood? So they don't have a definition of the word science. And so when you disagree with the definition, scientific definition I just posted, let me post that one more time. There it is. Okay, let's put it over here. Science rational explanation. You don't like that definition? Come up with one. That's your only recourse. And be able to defend it. It's not yours. We're not talking about opinions here. We're talking about, or my definition or your definition. No, we have to defend the definition. We have to be able to use the word science in a consistent way, in a rational way. So it's not just any definition you want to say, well, science is Hollywood or whatever. No, you gotta be able to defend your definition. You gotta get in the ring and fight for it. Okay? We don't agree in science. We don't agree to definitions. We don't agree to theories. In science, we fight for them. Get your shield, get your sword, get in the ring, get your gloves. You gotta fight for your theories and your definitions. And your assumptions. You gotta defend those as well. Okay, all geometric figure like triangle, circle, etc. are type of shapes, so we can't say circle has shape because it's like saying shape has shape. My God, some people are really drowning in a drop of water. Okay, let me get this thing up here. Here's a triangle, 2D. Does it have shape? Yes or no? I see something. I see contrast. I see a shape. We're done. That's it. I don't know what else to say. There it is. There's shape. Okay. Now he says shape is shape. Well, yeah, shape is shape. Shape is shape. Shape is what you just saw. That contrast, that triangle there, that's a shape. It has the same property as any other object in the universe. Shape. Some kind of, you can call it border. You can call it boundary. I hate the word perimeter because it means you run around, but we can even use perimeter as long as we put it in a contextual, in a proper context. Shape is shape. What can I say? This is simple. This, again, kindergarten stuff. People who can't get past that, they have major problems. Okay, another comment here. Well, it says, what is the economy, Bill, in your words? A concept, right? It's based on an object. Well, it is a concept, but based on an object, I have no idea what this guy's talking about. So it's a rational concept. Yeah, whatever that means. But you said economy is ecology. No, I didn't, but I don't know where you got that. In your words, not in any other words, okay, is the economy an object or a concept? Well, I thought you said it's a concept. I don't know where you got this, that it's an object. And again, these people drown in a drop of water. This is very simple. It's a concept. What is a concept? A relation. Okay, period. We're done. It's not an object. There's no standalone object called economy. We're done. It's so easy. Can you name and point to me the object? I have no idea where this guy got all this stuff, what's going through his brain. It has nothing to do with anything I said, at least. I don't know where he got it. Anyways, here's, just in case I'm going to answer one question there. And he wrote a lot, but there's nothing to address until he gets the basics right. I mean, if he can't get this right, the rest was nonsense. Okay. Anyways, here it is. Economy, management of resources. That's what economy is. Management of resources, a concept. There's no physical object called management. Okay, so it's essentially management. That's the key word. All animals manage resources. Okay, all animals have an economic system. There's no such thing as an animal that does not have an economy. Even ants, bees, everyone has an economy. Everybody's taking care of business every day. When a species or group of species can no longer manage the most fundamental of resources, food, Okay, that's when they go extinct. Okay, and yeah, that's going to happen to us. We're we're not going to be able to manage food anymore, and because we manage food through money. Money disappears, food disappears. No one has any incentive to produce food. So that's the theory. I'm not going to go into all that right now, but that is the theory. The theory is that we're going to die just like the dinosaurs died. When their food disappeared because they couldn't manage it any longer, not because of their fault, because it just disappeared under their feet. Okay, they had nothing to eat. First the herbivores died, then followed by the carnivores, and we're more or less in the same boat. Right now we eat both animals and plants. When they disappear, we have nothing more to eat, and 8 billion people can die in a matter of weeks. And you say, well, why would they disappear? Well, right now we produce food. We are the producers of food. See, unlike the animals, they go out into the wild and they get whatever they can find. Okay? So for them, it's whatever they find. And if you can't find it anymore, they die. And in our case, we grow it and raise it in the case of, animals. And why do we do that? Do we do it to keep ourselves healthy? Do we do it to distribute to the cities, to our fellow man? No, we do it for money. We do it for profits. We do it to make ourselves rich. And if money suffers a catastrophe for whatever reason, okay, they have no incentive anymore to produce food or distribute it to the cities. And then you'll see thousands, millions of billions of people die. Why? Because they have nothing to eat. No more food is produced on the planet. Okay, and so all you got to figure out after that is why money will disappear. Okay, so all we have to do is find out why the economy is going to crash. That's the only issue. We don't have to worry about asteroids. We don't have to worry about viruses. None of that matters. We don't die because of viruses anymore. We don't die because of asteroids or catastrophic accidents such as volcanoes or supernovas. No, we're going to die because our economy is going to collapse. No doubt about it. Long story. Won't deal with it today. Another comment. They're at the bottom, so it takes a while to get these things. An object is a person, place, or thing, right? No. Honk. Again, person hasn't passed kindergarten physics. So what is an object? Let's find out why this is not an object. No, here it is. Okay. Contrast that there. Object, that which has shape. Scientific definition of the word object destroys all religions, first of all. And a lot of people feel threatened. That's why they object to the word object. A place is not an object. Okay. That's a location. Thing is a synonym of object. So you can't say that a thing is a thing or an object is a thing. No. Thing is a synonym. Thing is not a definition, in other words, of an object. You can't use the word thing to define the word object because they are synonym. Synonym is a circular definition. In other words, no definition at all. So yeah, an object is that which has shape. It's not a place and it's not a thing. It is a thing in the sense that it's a synonym. All you're saying is an object is an object. That's all you're saying. So you can't use the word thing in the definition. Okay, continuing with another comment here. Oh, long one here. Why do we say space to indicate the portion of the sky beyond what surrounds the Earth, also empty space, black space, etc.? Okay, can a concept be a part of physical existence? I don't think so. Can the universe be composed of objects in space? My opinion is no. Okay, let's go through each one of these. I think I broke them down. Give me a second here. Let me get this thing up there. Let's put them face to face. Okay, here it is. Okay, so let's see. Why do we say space, etc., etc.? That's ordinary speech. So what you're doing is introducing ordinary speech into the scientific environment without understanding that you're doing that. It's unwitting. You do it and you're not realizing that you're doing that. You're introducing words which are undefined, what you're used to talking about in ordinary speech, the way you use them in ordinary speech, and without knowing you're introducing them into physics. You're going to see this constantly here. Can a concept be a part of physical existence? No. Exist, object plus location. Scientific definition, okay? Concepts do not have location. Can the universe be composed of objects and space? My opinion is no. Yes, universe is, the definition of universe is object and space. Universe is a concept, it's not an object. Universe does not exist. You can't say universe exists because that's ordinary speech. Ordinary speech. Ordinary speech. You're introducing ordinary speech, your notion of universe and your notion of exist, that from ordinary speech, you're introducing that into a scientific environment. You don't realize that. That's the problem. The space does not exist. Yeah, because it's nothing. So you cannot say that space exists. It's a concept. It means nothing, literally. And if it does not exist, then how can it be a component of the universe? Yeah, because the universe is object in space. Universe is a concept. There is no physical object called universe, no standalone object called universe. How do you get this through people's head? Which instead exists. No, it doesn't exist. Universe does not exist. According to that, only in religion, only in ordinary speech can you say the universe exists. According to the hypothesis of a single or primordial fundamental thread, no, absolutely not. This guy thinks that the single thread exists. No, it doesn't. Okay. And again, it's contextual. That's why I put the approximately equal, meaning that it depends on what you mean by exists. It's a long story to explain why the single thread, you cannot use the word exist in relation to it. So you got to be very careful when you talk about the single thread and the word exist. Again, what was it? I said it in the last couple times. The fact that if you have more universes out there that are not connected through the ropes to our universe, then you can talk about universes, meaning that each lump of matter out there constitutes what you could call a universe. In that sense, you could say that our universe exists because it has location with respect to those other universes. If all matter in the universe is interconnected by the rope, and we can't figure that out, right? This is just speculation. If all atoms are interconnected, then we cannot talk about the existence of the single thread. It's irrational. It doesn't follow from the definition of the word exist. So you got to be careful when you use the word exist, the word universe, period. Don't bring words of ordinary speech into science. According to your hypothesis, the universe is enclosed by a thread, an object. Absolutely not. The thread does not enclose absolutely anything. Okay, this is not like a ring enclosing the finger or something like that, which gathers the whole, so the space within this fundamental thread has a shape. Absolutely not. The whole does not have shape. The way we figure this out, we get rid of the thread and we find out what's left over. Is there something when you remove the thread? Okay, that's the question. And here's the single thread universe. Okay, and so let's assume this is, we opened up all matter and we have a single thread just twirling around itself, right? Out there, we can say in space, meaning not that it's within boundaries, it's just floating. That's it. One corner of the thread is moving with respect to the other corner of the thread. That's all we're seeing there, okay? The black stuff is not there, essentially. It just provides the contrast. And so that we can visualize the thread. Well, the thread is not enclosing anything within it, okay? There is nothing being cornered or encapsulated or pressured by the thread, okay? If you remove the thread, there will be absolutely nothing in the middle of where you see the thread now, okay? There will be nothing within that circle if you remove the thread. And that's the way we find out if space has shape. We don't enclose it with the thread and say, oh, see, space has shape because, see, I enclose it within the thread. No, it has shape is the thread. If you remove the thread, is there a standalone object called thread, called space, with some kind of shape there? And the answer is obviously no, because space is that which doesn't have shape. That's the definition of space. So no, it has to be a standalone object. Standalone. You can't put two objects in there and say, talk about the space, which provides the contrast, and say, I see, I've encapsulated space with a thread. You can't do that. You got to get rid of the thread because you're talking about not the thread, you're talking about space. And space has to be a standalone object. you're gonna have to enclose it with something. That's the issue. Otherwise you don't see any. All you see is black stuff like you just saw. So no, the thread does not enclose anything, universe or space or anything like that. Okay, final comment, but this one was a lengthy one. Okay, Paul says, how can we estimate the truth of compared different explanations other than by testing them by means of experiments? Like how Aristotle explained that heavier objects fall faster before Galileo made the experiment. Let's find out. He seems to think, right, that internal consistency alone is enough to secure the truth of an explanation. But the Greek philosophers, medieval scholastics, etc., were internally consistent and still wrong. Oh man, this guy's got to take an introductory course in science. Let's find out all the errors he made here. Okay, let's go with the first one. Let's put them in the proper context here, okay? And so we have the first one. Truth is an element of religion. So anyone introducing the word truth is a religious fanatic. He's talking about religion. There is no such thing as truth in science. Your truth is not the same as your neighbor's, okay? So never use the word truth in science. That is a hallmark of someone who is a religious fanatic. Experiments do not prove theories. So anyone talking about proof, evidence, is again talking about religion, okay? We do not prove theories, an explanation of a mechanism by running an experiment, okay? You can objectively put something on the screen as long as you understand it, that's fine. Prove it, that's on the eye of the beholder. Experiments cannot tell you the architecture of an invisible, intangible entity, such as light or gravity or magnetism. So you can run all the experiments you want, but if it's intangible and invisible, you will not be able to figure out what it is. Okay, so experiments have no purpose other than to convince you or persuade you of something, to prove to you, not to anybody else. Therefore, experiments cannot tell you the invisible mechanisms that underlie light, gravity, magnetism. Truth of an explanation is a personal opinion, religion. Wrong and right, also incorrect, correct, true, false are opinions, beliefs. And the Greeks and medieval theorists had irrational explanations because, like the mathematical mechanics of today, like everyone today, they used the particle to simulate their explanations. That's why they were wrong, as you say. Not that they were wrong, they were irrational, because you cannot explain any of this with particles. That's the problem. Aristotle also talked about, he was thinking about push. You have push gravity and so on. But I want to address this other issue here, because this shows this guy never even did a minimum of research on the subject. I want to clarify this one more time for everyone, just to make sure everybody gets it. Because if I see this again, well, then I'm going to issue another fatwa, okay? It says, like how Aristotle explained that heavier objects fall faster before Galileo made the experiment. Let's make sure we get this really right, okay, once and for all, okay? Let me get back in here. I want people to understand here, but I'm gonna beat them with this, okay, my dough roller. Fatwa, issue a fatwa, okay? Here it is. First of all, let's make sure we all understand this once and for all, okay? These people did the experiment way before Galileo. Galileo is a latecomer. The only reason we talk about Galileo today is that Newton mentioned Galileo because he studied Galileo's last book, okay, The New Science, and that's where he got his ideas for gravity. And apparently Newton was not aware of any of these fellows. Especially, here you have John Philoponus, and he was from the 6th century, okay? And I'm just going to mention two of these guys. All these people had already done the experiment of the two balls falling from the tower. I'm just going to mention a couple of these, okay? First one is John Philoponus, okay? Let's go with him because he's 6th century. This is what he wrote. This is what we have on the books from John Philoponus, okay? Just so you don't never make the error again, okay? But this view of Aristotle is completely erroneous, and our view may be completely corroborated by actual observation more effectively than by any sort of verbal argument. Listen what he's saying, the 6th century, okay? For if you let fall from the same height two weights, one many times heavier than the other, you will see that the ratio of the times required for the motion does not depend on the weights, but that the difference in time is very small. Now, whether Philoponus did the trick or not, whether he threw two balls or not, but it seems like he did because he does talk about that. Okay? But let's go with someone who did do the trick. And by the way, he wasn't the first one. The first one was that other guy you saw up there. I'm just going to mention Simon here because he did the experiment. He wrote about it. Okay? And so you can find it in his book, Simon Steven, okay, a guy from Holland. Aristotle and his followers hold that if two similar bodies fall, and again, they fall at the same time, the experience against Aristotle is the following. Let us take, as the very learned Mr. Jan Cornet's, the Groot, most industrious investigator of the secrets of nature, and myself have done, two spheres of lead, the one 10 times larger and heavier than the other, and drop them together from a height of 30 feet onto a board or something on which they give a perceptible sound. And you can see the tower there. That's the tower in Holland where they did this experiment. This was in 1586 when Galileo was only 21 years old. Okay, he was a nobody at the time. So this guy was writing this in his book. This is when he published it. Okay. Then it will be found that the lighter will not be 10 times longer on its way than the heavier, but that they fall together onto the board so simultaneously that their two sounds seem to be one and the same rap. The same is found also to happen in practice with two equally large bodies whose gravities are in the ratio of 1 to 10. Therefore, Aristotle's aforesaid proportion is incorrect. Okay? So Stebbins already did this experiment way before good old Galileo. So anyone who mentions Galileo is a person who's an idiot. Okay, let's put it in blunt terms. It's a guy who hasn't done any research whatsoever. And that's 90% of the people who teach at the university. They haven't even gone in there and tried to figure out if this is true or not. Okay, and let me show you something else here. This is Aristotle's gravity, the way he saw it. This is where they got this. Okay, this is Aristotle's gravity. He said, because it weighs more, earth sinks in water, water sinks in air sinks in fire, and fire sinks in ether. This is how Aristotle saw this whole thing, gravity, what he called natural motion. He says, just it weighs more. That was his explanation. What do you mean it weighs more? Why does it weigh more? So he had no explanation for this. He just says, oh, earth sinks in water because it weighs more. Why does water is underneath the air? Well, because it sinks in air because it weighs more. How about air below fire? Because they thought air was covered, with fire out there. They didn't see fire here on earth. They said it must be out there. And then, of course, they invented the ether, which is another type of fire. It's a godly or holy fire. And that was beyond their reach. It was only between the earth and the moon. This is how Aristotle saw gravity. This was his notion of gravity. Of course, it was, you can pardon him because we're talking about 2,500 plus years ago. Okay, so no. First of all, yeah, Aristotle had it wrong, but he wasn't the first one. The people who came after him did the two-ball experiment, dropping them from heights. They did it way before Galileo, and Galileo, as far as we know, he never did the experiment. And let me tell you why. He was under house arrest. He was under house arrest prior to writing his book. He wrote his book in 1638, 4 years before he died. Okay, 5 years before Newton was born. Okay, that's when he published his book. But he was under house arrest because he had been sentenced by the Vatican, okay, by the Catholic Church, by the Inquisition. So he was under house arrest. I doubt very much he went to the tower, especially at his age. He was close to 80 or in his 80s. And so he didn't go up there with two balls and drop them. Now, he did a lot of this stuff before. He did it like in 1604, many years earlier. The question is whether he ever went to a tower and dropped the two balls. Maybe he did, maybe he didn't. He never documented it, so we have no evidence that he did this at all. No, nothing in writing from Galileo. So no, there were people who did it before Galileo. Don't ever mention Galileo again. That's only for people who have done no research whatsoever. Okay, and they just parrot what they heard out there from someone else. Do the research, and you'll find out that Galileo was not the first one. And then it is, the issue there, anyways, is that if if Galileo did it or not is irrelevant anyways, because they always talked, even Aristotle talked about resistance. Even the flat earthers talk about resistance. In other words, density. Does it fall in water? Does it fall in air? Does it fall in molasses? So they looked at all these different medium. Okay. And with that, I guess I'll call it another day, and we'll see you. What is it? Sunday? We'll see you then. Bye-bye.